All right, here we are. Next one. Next part for free response questions 2022 AP Physics 2. We're going to calculate the amount of charge on the 200 microfarad capacitor. We know C is equal to Q over V. Thus Q is equal to CV, which is 200 times 10 to the minus 6 times 0.91 volts. And that's in farads. Farad volts gives me coulombs, which is 1.82 times 10 to the minus 4th coulombs of charge. That one's pretty simple. All we do is just plug into this guy over here. Briefly explain why the data in the table provides evidence the capacitors are connected in series. Okay, so things that are in series, I'm going to draw over here. Things that are in series, whether they be capacitors, resistors, inductors, whatever. If we have the source voltage here, voltage supply, then we have this one capacitor, another capacitor, and let's call this Vs, and the voltage across this guy is V1, and the voltage across that guy is V2. What do we know here? If they're in series, V1 plus V2 must be equal to Vs. So let's see if that's the case here. We're actually given the voltage across each of these two. So if I add these up, 0.91 plus 3.52, these sum to 4.44 volts. These sum to 4.39 volts, and I can keep going, but I'm getting a value that's close to 4.5. And I know from reading the previous information that the students are using a battery of potential difference 4.5 volts. So I see here that the voltage supply is equal to the sum of the two voltages across the two capacitors. That's very good evidence that they're actually in series. So I would write something along the lines of things that are in series have to have their voltage sum to the source voltage, and the data reflects that because everything that I sum up is extremely close to 4.5 voltage, 4.5 volts. I'm not going to write that in a full paragraph form, but mentioning that the sum of the voltages equals 4.5 volts would be a very key thing to write. For the next one, briefly explain why connecting the capacitors in parallel wouldn't provide enough information. Okay, so I'm going to draw a little thing here. For the previous one, I drew them in series with one another. Now they're going to be in parallel with the source. So if this is, Vs, we know things are in parallel have the same voltage across them, so that's Vs and Vs as well. And let's let this be the known capacitor and let this be the unknown capacitor. So I know the unknown capacitance is the charge on the unknown divided by the voltage on the unknown, which is actually just Vs. And the capacitance of the known one is equal to Q of the known divided by Vs. What's up with these two charges here? They're not the same. And this C is known. This Vs is... Wait a second. If I was to solve for Vs, I can set them equal. So that would be Q unknown over Cu is equal to Q of the known divided by C known. Yeah, the problem here would be we don't know what the magnitude of the charges on the plates are. If we knew what these were, I could easily just solve for this Q unknown as well. And we could solve for it with like a graph or something. But because all we have is a voltmeter, and they tell you that, the only device available is a voltmeter, I can't find the charges. So I'd write something along the lines of capacitors in parallel, you need the charges. Since all we have is a voltmeter, this is impossible.